young math Padawans, it's Mrs. Angel with your lesson for today on solving tougher two-step equations. So first, how do we know which property of equality to use? Well, that doesn't change. If the equation is a sum or a difference, like you see in the examples here, we're thinking about using SPO and APO to create those zero terms. That will get x by itself. If the equation is a product or a quotient, as you see here and here, we think DPO or MPO to create those big one factors. So what makes a two-step equation tougher? Well, if we look at both of these equations, you're going to notice something different about the constant, the variable term, and the coefficient. So let's start with the equation on the left. If I look at this equation, how many terms do you see on the left side of the equation? There's actually only one term here, and it's the entire thing, 2 times the group of x plus 5. This is just one term. And what kind of term is this? Well, since we clearly have 2 times everything going on inside of the parentheses, we would say that this term is a product, meaning multiplication is currently happening. That means if we were to continue on, 2 here is our coefficient. That's the part that's being multiplied. And actually, our variable and our constant are trapped inside of what we call a group. So that's what makes this a tougher equation. If we look over at the second equation, we notice the same thing. There is only one term on this side of the equation. As opposed to the first one, we wouldn't call this term a product though, because everything is being divided by 2. So this term is what we call a quotient. That would mean that 2, in this case, is our coefficient. That's the part that's either being multiplied or divided. And again, everything else, our variable term and our constant, are stuck in a numerator. And a numerator is essentially the same idea as a group. I can't break them out of that group without first dealing with my coefficient. So let's talk about how it is that we actually solve these equations. So starting with our first equation here, before I do anything else, I'm putting a line down the middle of my equal sign. So since we have a single term here, we're actually going to do the steps in reverse. Because 2 is our coefficient, it's the number that's attached to this term, we're going to start off by making a big 1 using MPO or DPO. Now, if I look at this, this is 2 times x plus 5. So multiplication is already happening, meaning I would not multiply again. I would divide to make a big 1. So here's what that looks like. If I divide this side by 2 and divide the right side by 2 as well, you can actually see a big 1. It's right here. 2 divided by 2, well, that's just 1, which means we have one set of x plus 5 left. So x plus 5, our group, is left over, and 10 divided by 2 is 5. Now, what did we accomplish? Well, if you notice, now our 2 terms, our variable and our constant, have broken out of this group, which means we can now use our addition and subtraction. So step 2 here, once you've used that big 1, now we're going to identify our constant because it's out of that group, and our goal is to make a 0 term. So our constant here is our plus 5. We're going to make a 0 term using subtraction, SPO. Since that's a positive 5, we would subtract to make 0. So subtract 5, And our new equation, well, let's see. 5 minus 5, that's 0. So we're left with x, and 5 minus 5, that's 0. So it appears that our solution here is 0. Now we have to check. So to check the solution, I'm just writing the original equation. I'm just replacing x with 0. And we're going to see if this is true. 0 plus 5 is 5. And does 2 times 5 equal 10? Yes, it does, which means the solution is x equals 0. Let's look at that second example now. Again, I notice that we have a single term here. That poor constant -5 is stuck in the numerator. It's stuck in the group. So we cannot start with adding or subtracting. So let's look at our first step here. We're going to start by finding the coefficient. Well, we know that. That's the division with 2. I'm dividing by 2. We're going to make a big one with MPO or DPO. Well, let's think for a second. If I'm already dividing, would I divide again? I don't think so, which means we're going to use MPO here to start. So before I do that, I'm going to put the line down the middle of my equal sign. And now I know we're using MPO, multiplying both sides by 2. What happens? Well, once again, we've made a big 1 here with these 2's. 2 over 2, we know that is a 1. And that means we're left with what the original numerator was, which is x minus 5. On the other side, 10 times 2, well, that's just 20. And by doing this, we have broken our constant out of that group. Our constant is now standing on its own, which means we can go on to step 2. We can make a 0 term using APO or SPO. Well, since our constant here is negative, we would use APO to finish this equation and add 5 to both sides. -5 plus 5, we know that is a 0 term, which leaves us with x, and 20 plus 5 is 25. Of course, now we're going to move on to step 3 and check. So to check, I'm replacing x with 25 in the original equation, and I'm seeing if it is true. So we start with the numerator, 25 minus 5, that's 20. Does 20 divided by 2 equal 10? Yes, it does, which means the solution to this equation is x equals 25. Now let's get into our practice. So looking at this first equation, if I put the line down the middle of the equal sign, I see on the left side here, I have a single term. I've got a big quotient happening over there, which means I'm thinking I want to use MPO or DPO first before I try to get rid of that constant. So go ahead and try solving this equation on your own now. All right, let's see how you did. So the first thing I saw was that my coefficient here was that I'm dividing by 2, and I wouldn't divide again. That leads me to believe that my first step would be MPO and multiply both sides by 2.
Multiply by 2, multiply by 2, that makes a big 1.
And my new equation is -5 plus x equals 10. Now I'm able to identify my constant as -5, and I know I'm going to use APO to make a 0 term.
Add 5, that makes 0.
And after my check, I see that it is a true equation, and the solution is x equals 15. Last example for this video, I put a line down the middle of my equal sign. And I'm only concerned with what I see on the left, which again is a single term. In this case, I'm multiplying by -9. So I'm thinking make a big 1 first, then I can tackle the constant inside the group. So go ahead and try solving this equation now. Let's see how you did. So again, I identified -9 as my coefficient, and multiplication is already happening. So I wouldn't multiply again. I would start off with division and divide both sides by -9 to make that big 1. -9 divided by -9 is 1, leaving me with everything that was originally trapped in that group. 5 plus n is now outside of the group, and -45 divided by -9 is 5. So now that my constant is outside of the group, I can think, well, APO or SPO. How do I make 0? I would use SPO here and subtract.
-5, which makes a 0 term.
And my new equation is n equals 0. Of course, I still have to check. And my check worked out, so I know the solution is n equals 0. So to quickly recap, a tougher two-step equation is an equation that only has one term, but still requires two properties of equality to solve. That's it for today's lesson. I will see you next time.